Hey guys, in this video you're going to learn how to integrate by parts using the tabular method, which has to be the quickest and most efficient way to integrate by parts, especially when you have to integrate by parts multiple times. But first, let's talk about when you should integrate by parts. Usually you want to integrate by parts when you have a product of two functions. But before you commit to integrating by parts, quickly check, can I integrate this using the reverse chain rule? Assuming that you can't, then ask yourself, if I were to integrate one of these functions and differentiate the other one, would I then be able to integrate the product of these two new functions? If that's a yes, then you're ready to integrate by parts. So our first example is the integral of x cubed times ln x. So when you're integrating by parts using the tabular method, the first step is to draw a table consisting of 3 columns. The first column contains the signs, and it's always going to alternate between plus and minus, and it's always going to begin with a plus. The second column is for the function that you're differentiating, and the third column is for the function that you're integrating. And so with that being said, how do we decide which function we're differentiating and which function we're integrating? Well, as a general rule of thumb, always avoid integrating logarithms because they're only going to get more complicated when you integrate them. And the same goes for inverse functions. So instead, let's differentiate ln x and let's integrate x cubed. So when we differentiate ln x, we get 1 over x. And when we integrate x cubed, we get x to the power of 4 over 4. And the point at which you can stop differentiating and integrating is when you see that you can integrate the product of a row. So here we can clearly integrate the product of 1 over x and x to the power of 4 over 4, and so we can stop integrating and differentiating at this point. The first term of our answer is the product of ln x and x to the power of 4 over 4. And if we had more rows, then we'd continue that pattern until we reach the row where we have the integral. And so the integral is the product of this row, which means we have the integral of minus 1 over x times x to the power of 4 over 4 dx. So let's simplify our integral, and we end up with, if we factorize out the minus a quarter, we have minus a quarter. The x is going to cancel with one of the x's here, and so we end up with x cubed dx, which means our final answer is x to the power of 4 over 4 ln x minus x to the power of 4 over 16 plus c. And if you're getting value from this video, then consider subscribing and hit that bell icon so you never miss a thing. Our second example is the integral of x squared times e to the minus x. So for this integral, let's integrate e to the minus x, and let's differentiate x squared. And we have our pluses and minuses on the left. So the derivative of x squared is 2x, and the integral of e to the minus x is minus e to the minus x. Let's go to the next row. The derivative of 2x is 2, and the integral of minus e to the minus x is positive e to the minus x. And we can definitely integrate this row along here, which means that we can stop differentiating and integrating here. And so the first term of our answer is positive x squared times minus e to the minus x. So that's minus x squared e to the minus x. Our second term is negative 2x times e to the minus x. And our integral is positive 2 times e to the minus x. So the integral of 2e to the minus x dx. So our final answer is negative x squared times e to the minus x minus 2x times e to the minus x minus 2 e to the minus x. And let's not forget the plus c. Here we have the integral of x times inverse tan x. And like I mentioned earlier, whenever we can, let's avoid integrating inverse functions. So let's differentiate inverse tan. And let's integrate x. And we have our pluses and minuses on the left. So when you differentiate inverse tan, you get 1 over 1 plus x squared. And when you integrate x, you get x squared over 2. And we can probably stop here because we should be able to integrate x squared over 2 times 1 plus x squared. So the first term of our answer is going to be x squared over 2 times inverse tan. And our integral is going to be minus, and let's take out the half, so minus a half times the integral of x squared over 1 plus x squared. And I think the easiest way of integrating this fraction is if we add 0 in a sort of clever way. So x squared over 1 plus x squared is the same as 1 plus x squared minus 1 over 1 plus x squared, because we've added 1 and we've subtracted 1. And then we can split this fraction into two fractions. So we have 1 plus x squared over 1 plus x squared, which is 1, minus 1 over 1 plus x squared. And so let's replace what we have here with our new form. So our final answer is x squared over 2 times inverse tan x minus a half times the integral of 1 minus 1 over 1 plus x squared dx. And so we get x squared over 2 inverse tan x, so minus a half x. And of course this is the derivative of inverse tan, and so we get positive a half inverse tan x plus c. Hey guys, thanks for sticking around. I hope you learned something new from the video, and comment down below what video you want me to make next, and I'll see you next time.